And we're going to do a recap of Avogadro's hypothesis. Now, earlier in the school year, we covered this back on page 98. So notebook page 98 was the first time we talked about Avogadro's hypothesis. So Avogadro simply stated that when you have equal volumes of different gases, so gas A, gas B, and they are being held at the exact same temperature and pressure conditions, he states that they will contain the same number of moles and they will also have the same count of molecules. So you can write molecules or particles. So let's take a look at this question. If you have 5 liters of neon being held at STP, standard temperature and pressure, why does it contain the same number of molecules of 5 liters of xenon also at STP? So if you explain why they have the same number of molecules. So it's basically restating the hypotheses. The reason that the neon sample and the xenon sample have the same number of molecules because they have equal volumes of gas at the same temperature and pressure conditions. Therefore, their number of moles and their counts are exactly the same. Let's take a look at a couple of practice multiple choice questions applying Avogadro's hypothesis. So, at the same temperature and pressure, which sample contains the same number of moles of particles as 1 liter of oxygen gas? So we have 1 liter. So when I go and look at my responses, right away, I'm going to eliminate response B and response C because they are different number of liters than the one in the question. So that leaves response A and response D. They both say 1 liters. So when you have 2 answers that look like they could both be legit answers, you got to take a look at all of the other information. So Avogadro's hypothesis, it says equal volume of different, where'd my pen go? Different gases. So when you take a look at these 2 responses, this is a gas, but when you look at response B, this is a liquid, which means for this question, this is in the wrong phase. So D is not the best answer because of the wrong phase. So A is the best answer here. Question number 2. Which sample of gas occupies the same volume as 1 mole of helium at STP? So in our question, 1 mole. And when you take a look at the responses are in various units. We have liters, we have a count, we have grams, and we have moles. Okay? So if we have 1 mole of helium at STP and our other gas is also at STP, well, we can eliminate D because it's the wrong number of moles. To pick out the best answer from A, B, and C, we've got to think about things that we learned from the mole diagram. So 1 mole of any gas at STP, it will occupy 22.4 liters. 1 mole of any sample means it will have a count of 6.02 times 10 to the 23 particles. And 1 mole of any substance, if we put it on a digital balance, that 1 mole will have a mass that is equal to the GFM, so the gram formula mass value of that sample. So when we take a look at response A, it's in liters, so we have to compare it to this one. Well, 1 mole is 22.4 liters. This one is not 22.4, so it's not the best answer. Atoms would be an example of a count, just like particles. So 1 mole has Avogadro's number as a count, 6.02 times 10 to the 23rd. And we look at this one, it says 10 to the 24th, so it's the wrong count. So that leaves us with answer C. It should be the best answer. So what we want to do is determine the GFM of H2. Well, there are 2 atoms of H. Each one contributes a mass of 1, so its GFM would be 2 grams per mole. And this 2 grams matches the GFM, so C would be the best answer in this case.